So in this case, I want us to consider our typical exam question that we wrote recently so that we can see how we are supposed to attempt these typical questions that we had in our July examinations. So make sure that you do understand if you're the one who wrote in these exams, that is a chance for you to actually see, okay, where are the errors and to actually prepare yourselves for a next level or to prepare yourselves for the same level that you were doing, depending with what you are seeing according to the way that you also answered. So that is the major purpose of us revising. So in this case, we are going to note that we were given our question paper, which had the information that makes sure the most important part you were given to answer question 5.15 and 5.2 on the provided addendum A attached, and also 5.32, it was also on addendum B. And you also to write your examination number, this and that, which is important. And make sure that you just write clearly. So I'm not going to waste much time. I'm going to quickly rush into the questions that we were given so that we see how we're supposed to attempt these typical questions. So if we are to consider this first part, which is our question number one, we are going to see that 1.1, we are given a girl age, okay, took her age, multiplied it by 4. All right, so she took her age, meaning to say we do not know her age. So let her age be X. Let the girl's age be X. That's the girl's age. Bx, okay? So we can understand this much better. So she multiplied this by what? By 4. So meaning to say this x, she multiplied it by 4. That is what the statement is saying here. That is 4 times x. She multiplied it by 4. 4 times x, which is 4x, okay? Then what happened after that? Added 4 to it. After multiplying by 4, she added a 4, okay? So this is what she did. She multiplied by 4 and she added 4 to it after multiplying and got her grandfather's age. So take note. The answer that we are going to get here is supposed to be what? The grandfather's age. And we are told if your grandfather is 100 years old, we are given his age. So here we have got the age of the grandfather, which is 100. We are told that is the grandfather's age. So the question was, how old is the girl? Remember, your age is what? Is X. So to solve for X is to find the girl's age. That's the question there. The moment you just solve for X, you are finding the girl's age. That is how old is the girl. So let us solve for X. That was our question there, right? So we can simply solve for X. This is a linear equation. So we can take the 4 to the other side of the equation so that it can be a negative on this side. So that was going to be 100 minus 4, which is 96. So you subtract a 4 on this side. So we can obtain the value of X by dividing by 4 both sides. So meaning to say our X was going to be what? If you divide this, you were going to obtain 24. So that means the girl's age in this case is supposed to be what? Is supposed to be 24 years old. Okay, that is if you take this 24, apply this statement, you're supposed to obtain exactly what we are given as his grandfather's age, which is 100. Okay, that is 4 times her age, which is 24. After that, you add a 4 to that. You must obtain 100. Okay, and that is exactly what we are obtaining there. So that is our question. Let us consider another part that is on question 1.2, which is 3 marks. Okay, 1.2 you are given to solve the following equation. All right. They did not end there. Follow the instruction. They are saying by using the factorization. This is the important part, the most important part. By using which method? Factorization method. So you're not just solving this equation by your own way. You are using a method that you are given, which is the factorization method. All right, so let us consider our equation, which was 8f squared minus 6f plus 1 is equal to 0. Remember, factorization, you need to factorize this. All right, you're going to factorize this part of our quadratic expression. How do you factorize? That is in your hands. How do you going to factorize that? It's in your hands. This is not a 1. Remember, if the coefficient of this is 1, you just put your brackets, which is fine in whatever way that you can consider. But remember that we can factorize this in many ways. So I'm just going to consider this one. In this case, which is most of us, we use this where you multiply the first term and the last term. So you're going to multiply the first term and the last term, provided that we have got the highest exponent of 2. So 8f squared times 1 is going to give us 8f squared. So this is what you're going to do. You need the factors of this 8f squared, which are actually the products, 2 factors, or the products. These terms are supposed to give us the same 8f squared. But when added, they must give us this middle term when added. So as we can say, the middle term is a negative. In a sense, you can think, all right, let me just consider 4 and 2, because if I multiply 4 and 2, I get an 8, which is true. But in your consideration, take note also of the middle term that it's carrying a negative. So to obtain a negative, I'm just going to put a negative here. So that means we are having the factors. Okay, let's multiply -4 and -2. What is it that we're going to obtain? That's a +8. If we add, because we need this middle term, if we add these factors, if you add them, they must give you this. So let's add -4 plus -2, that's a -6. On your calculator, you can simply add that. That is going to give us a -6, meaning to say we have got -4 plus a -2. That is a -6. The major part is when you multiply these, okay, you get a +8. But if you add, you obtain the middle term. If you add, you're obtaining the middle term, which is the -6. So with these 2 factors, we are going to substitute them into the middle term. Then we can factorize, all right? So in place of the middle term, let us substitute our factors, okay? Our terms, which are the products. So this is going to be 8f squared. We substitute these 2. So that is -4f minus 2f plus 1, which is equal to 0. So you substituted here. This is going to remain as it is. So now we can apply our factorization. Remember, by grouping, since we've got 4 terms, 1, 2, 3, 4, you can apply by grouping. Group into 2, then you factor out the highest common factor. Between these 2 terms, we've got 4f as our highest common factor there. Then we're going to divide 8 by 4, which is 2f minus 4 and 4 cancels. F and f cancels, you get a -1. So if we check, this is -2f plus 1. In this bracket, we have got 2f minus 1, of which these 2 brackets are supposed to be the same. We are supposed to obtain the same thing from whatever that you're going to factor out here. It is supposed to give us the same bracket as this one. So look, there's a negative, but this here is a positive. So what are we going to do so that this becomes a positive? We are supposed to factor out a negative. Remember, a negative divided by a negative, it gives us what? A positive. A positive divided to a negative, that's a negative. So these two brackets are the same. Remember, these two brackets are supposed to be the same so that you factor out that common bracket, the 2f minus 1, and you remain with what if you factor out it here? Remember, here you factored out a minus 1. Okay, a minus means there's a 1 there. So meaning to say there you're remaining with 4f minus 1. And this is supposed to be equal to 0. You are factorizing the normal way that you're supposed to do. But this is an equation, so you're supposed to equate everything to 0. Supposed to be careful on that. All right. So since we've got two brackets being equal to 0, we do understand that one of these two brackets is supposed to be equal to 0. So we can have it as an equation of 2f minus 1 being equal to 0, or the bracket of 4f minus 1 being equal to 0. So there we can calculate the value of f. So f is going to be what? Minus 1 on this other side. That's a positive 1. Then we divide by the 2. The minus 1 on this side, that's a positive. So meaning to say we are going to divide by a 4. Okay, so it's going to be 4f is equal to 1. You divide by what? You divide by 4. I think we are together on this part. So these are the values of f that you're going to have. But in an exam condition, you have obtained or you have calculated these values. You have calculated these values. You obtained your answers. You know that there is a quadratic formula. You know that there is a quadratic formula. Use that to prove, are these answers correct? Because you know that there's a quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. But in this case, we're not considering x. What are we considering here? F. We are calculating f. So meaning to say f is equal to minus b. Remember, this will be your a, your b, your c. So that means our minus b is minus 6 plus or minus the square root of b squared. Our b with there, which is minus 6. So that's minus 6 squared minus 4 times a, which is 8 times c. Our c is the constant there, which is 1. Everything over what? Everything over 2 times a, and our a there is 8. You have your quadratic formula. Use that to prove, are these answers correct? So we can actually use that. All right, so in this case, I'm just going to use the calculator direct. That's a minus, and the minus here is going to be what? A plus. So meaning to say there, we're simply going to have 6 plus the square root of minus 6 squared. So I'm just going to put a bracket here, minus 6 squared minus 4 times 8 times 1. All right, divide by 2 times 8. That's 2 times 8. And that was going to give us 1 over 2. So as you can see, we've got the same value. And if we just put a negative, just put this across the arrow, remove this plus and put a negative there, you can see that we've got 1 over 4. Exactly the same answers that you obtained by factorization. So that is supposed to be a reference. That is supposed to be like a proof, like when you're working these questions, you're supposed to also check, are you in the right direction? It's an exam. All right. Anyways, this is what you're supposed to obtain. In this case, 1.3 for marks. Let us consider this. Solve for x and y in the following simultaneous equations. So these are two equations, and we've got 4 marks for that. Solve for x and y. Okay, so let us see. We were given the first equation, which is 7x is equal to 6y minus 3. Okay. We can just consider this as our first equation. Or let me just write another one, then we can see what we can do from these equations before. All right, another equation, it was 3y plus 4x. All right, 3y plus 4x minus 1, which is equal to 0. So from this, you are asked to solve the following simultaneous equation. You're not told which method to use. Are you going to use substitution? Are you going to use the elimination method? It's in your hands. Let's say I want to use the substitution method. It's up to you. We can do that. Okay, so I'm just gonna start by the substitution method. Substitution method. So by substitution method, we can choose to make X the subject, Y the subject. As you can see, in all of these equations, it is actually difficult. Like we cannot say it's easier for us to make X the subject. We do not have an equation where we can just write X is equal to whatever that we want. All these, they are affected by the coefficients. Even the part of Y is affected by the coefficients. So there, you do not have a choice. You just have to choose which one do you want to make the subject. So I can just take advantage of this already. It's given as 7x is equal to. It's easier for us to relate from there. From equation 1, I can make x the subject. From equation 1, this is what I'm going to do. I'm simply going to divide. 7x is equal to 6y minus 3. Then I'm just going to divide by 7 by 7. So that means our x is equal to 6y minus 3, everything over 7 like this. All right. So if I'm to consider this, I'm now having another equation that I'm going to consider. Let us just say equation 3. So by substitution method, remember, you are going to substitute this into the other equation, not equation 1, where you made the subject, because remember, you made the subject from equation 1. So you're going to substitute in equation 2. So you're going to substitute in equation 2, whatever that we are having here. Equation 3 into equation 2 in place of x. So this is going to be 3y plus 4x, that is 4 times x. This is your x. That is 6y minus 3. Everything over a 7 like this. This is what is representing x. Minus 1 is equal to 0. So take note. You had whatever that you had before. This is a new equation that you're supposed to think of. How to solve this equation. We are no longer of simultaneous equations here. That's a normal equation because we've got y here and also have y here. But the question is, how are we going to solve? Are we going to remove the fractions first? Are we going to remove the brackets? It's up to you. All right, so in this case, I just want you to say that this is the same as writing this as 3y over 1 as a fraction plus this part here is the same as 4 into the bracket of 6y minus 3 like this. Everything over 7. That is what it means. This is the same as 4 over 1. So 1 times 7, 4 multiplies the numerator. Minus 1, 1 is same as 1 over 1, which is equal to 0. And 0 can be also written as 0 over 1. So meaning to say, we can consider our denominators in this case and find our LCD, which is 7. Okay, that's the lowest common denominator there. Multiply each and every term by the LCD or the LCM. So you're going to multiply each and every term by the LCD, multiply by 7, multiply by 7, multiply by 7, multiply by 7 to remove what? The fractions. So thus this is just going to cancel because 1 into 3, that's a 3, and 3 times 7, that will be 21. Y plus the 7 and the 7 here will cancel. Thus you are remaining with the 4 into this bracket. So you can write 4 into the bracket of 6y minus 3 minus 1 times 7, which is 7, is equal to 0 times 7. That's a 0. Remember, 0 times any number, that's a 0. So as you can see, we no longer have the fractions. We've got the brackets now. So you can consider expanding the brackets. So what term is going to be used? Positive 4. 4 times 6, which is 24. So that's 24y minus 4 times minus 3, which is minus 12 minus 7 is equal to 0. Then we can collect the like terms, 21 and 24. which is going to be 45. So that is going to be 45y in this case, minus 12 minus 7, that is minus 19. So we can take the minus 19 to the other side of the equation. So there it is going to be a positive 19. Simply divide by 45 both sides. So y is going to be 19 over 45. All right, you can also check on your calculator if this can be reduced or not. What's the advantage there? 19 over 45. So as you can see there, this one cannot be reduced. It is just going to remain as it is, 19 over 45. So you have got the value of y from the substitution that you made. You calculated the value of y. You are going to also substitute this y that you obtained into any of these equations. Are you going to substitute in equation 1, in equation 2, or in equation 3 to calculate the value of x? So as you can see, equation 3 is easier to work with. Why? X is already the subject there. If you are to check here, x is already the subject in equation 3. So we can simply substitute the value of y that you obtained to obtain x. X is equal to 6y minus 3. That's 6 times the y that we obtained, which is 19 over 45. Whatever that you're going to obtain, we subtract a 3, everything over 7. So do not even worry, because your calculator can simplify this part as it is. So let us see what we are going to obtain on our calculator. That's put a fraction. So we are going to have 6, open bracket. We're going to have 19 over 45, right? Then we're going to close this bracket, minus 3. Then we divide by a 7, everything divided by 7 as it is here. That's how your calculator is supposed to be displaying here. So this was going to be negative 1 over 15. So then we are going to obtain negative 1 over 15. That is the value of x. So we've got the value of x and also the value of y. So in a typical exam condition, you'll be say, okay, these values, they are actually awkward values, but that is what you're obtaining. So use your values as they are. All right. So just gonna consider also to play around with other methods. Like I said, you can use, or you can choose to use any method. That is, for the substitution, you need to make one of the equations the subject. It was up to you which one, but you're supposed to obtain the same values of x and y, or the same answers for x and y. Let us see if we are to apply the elimination method, because some of us, we might be used to the application of the elimination method. So using the elimination method, remember, we need also to have our equations in a format that we do understand the part of y on its own, the part of x, the variables on one side of the equation. So if you're to consider equation 1, okay, equation 2, we can see that there we are given x and y, which is fine, which they are positive. So we can also take the y this side, so that it can be written as 7x minus 6y is equal to the minus 3, which is remaining this side. Already here we've got x and y on the left-hand side. So I'm just going to start with x. So that will be 4x. Then the part of y here plus 3y is equal to the minus 1 to the other side of the equation. That will be a positive 1. So we can choose to have our equation this way. And with our equation in this way, it is up to you which part are you going to eliminate. Are you going to eliminate the part of x, or are you going to eliminate the part of y? If you want to eliminate x, interchange these coefficients that we are seeing. 4 multiplies on top, 7 multiplies this other equation. So we are going to multiply equation on top this whole equation by a 4, since we want to eliminate x. The second equation, we multiply it by a 7 so that these coefficients of x will be the same. Okay, let's multiply by 4 everything in the first equation. Multiply it by 4. That is 4 times 7. So I'm just going to have this as equation 1, equation 2. So 4 times 7, that is 28x. Okay, 4 times minus 6, which is minus 24y, is equal to 4 times minus 3, which is minus 12. You do the same thing. So this is going to be equation 3. You multiply everything here by 7. That is 7 times 4, which is 28x. 7 times 3, which is 21y, is equal to 7 times 1, which is a 7. So as we can see, in these equations that we have formed 3 and 4, the coefficients of x are the same. The power of x here is the same. So we can eliminate x. To eliminate is to remove that x, to get rid of that x, to remove it from our equation. We do not want x. So how are we going to eliminate x? Are we going to add these two, or we are going to subtract? So if we check, we are going to subtract. If we add, it is not going to work. It is going to be more than what we want. It is not going to eliminate x, but 28 minus 20, that's a 0. So I said if the two signs are the same, you subtract. Whether it was a minus here and there was a minus here, you subtract to eliminate as long these two signs are the same. So it's a plus and it's a plus, subtract to eliminate that term that you want to remove. 28 minus 28, that's a 0. So here we are subtracting. That will be equation 3 minus equation 4. So we are going to subtract. 28 minus 20, that's a 0. Minus 24 minus plus 21. We can even use our calculators there. That will be minus 45. Or you can just use your calculator like this. That is minus, okay, minus 24. So that's minus 24. Minus this one for subtracting. But what are we subtracting? A positive 21. So subtracting a positive 21, guys, this will be minus 45. So we have got minus 45y is equal to minus 12 minus 7. Also, you can just use your calculator there. That will be minus 19. Minus 12 minus 7, which was going to be minus 19. So that's a negative 19. So we can obtain the value of y by dividing by negative 45. That was going to be 19 over 45. So as we can see, we are obtaining the same value of y, which is 19 over 45. Definitely, we are going to obtain the same value of x from there. We can obtain the x now by substituting in any of these equations. You can substitute in this one. You can in any of the equations that you are having. So if you are to consider, in this case, if you wanted, you can just work with this one, where we are given 7x is equal to 6y minus 3. So 7x is equal to 6 times the value of y that we obtained, 19 over 45 minus 3. So since we want x, we divide by 7. We divide by 7. So as we can see, that was the same expression as the previous part that we had. This was going to give us the same value of x, which was going to be negative 1 over 15. So it's up to you. Which part did you eliminate? Maybe you eliminated y, then you calculated x, you're going to give this, you substitute, you are going to obtain your y as 19 over 45. So this is in your hands. Which method were you going to apply or to use? On 1.4, we were given a formula, and that formula we are asked to make on 1.41, make n the subject of the formula. All right, so let us consider our formula in this case, which is given as h is equal to the square root. All right, that's the square root of n to the exponent of 3 minus p t to the exponent of 3, everything over m. How can we make n the subject in this case? All right, we need to make n the subject. They are fractions, square roots. Okay, let's get rid of fractions first. This is the same as over 1. So you can simply cross multiply. This is going to be h times m, which is hm, is equal to 1 times the square root of this, which is the square root of n to the exponent of 3 minus p t to the exponent of 3 like this. All right, so this is where we are. We no longer have the fractions, but the n that we want here is hidden inside of the square root. It's inside. So the question is, how can we remove this square root? Because it's hiding the n that we want. It's inside. So remember, the opposite of the square root is to square. You square both sides. As it is, you're going to square this. So meaning to say, by squaring this, it means we got hm squared, or you can write this as h squared, m squared, everything to the power of 2. So this is equal to the square root when raised to the power of 2. We are neutralizing this, removing the square root. So thus we are going to remain with n to the exponent of 3 minus pt to the exponent of 3. So that's it. We no longer have complicated situations like the square root, this and that. The n that we want is here. But look, it is affected also by this term, which is just being subtracted. So how can we remove this? Just throw it to the other side of the equation. It changes its sign there. So it will be h squared, m squared. It was a minus. On the other hand, it will be a plus. So that's plus pt to the exponent of 3, which is equal to n cubed. So this is where we are. Remember, we want to make n. We removed the square root by squaring, raising to the power of 2. There we have got a power of 3. So how do we remove the power of 3? We introduce the opposite of that by this 3. We have to write the 3 also here. So it's going to be the cube root of everything in this case. The cube root both sides. So there's a 3. There must be a 3 here. So this neutralizes the cube root, the cube power, which is the exponent of 3, so that you remain with n. And this is equal to the whole of this part, which is the cube root of h squared, m squared plus pt to the exponent of 3. That's it. So in this case, we've got n as the subject of the formula, or you can just write therefore n is equal to the cube root of h squared, m squared plus pt to the exponent of 3. Okay, someone can also write this. Remember, from this hm squared, this one, you can also continue each and every part like that, hm raised to the power of 2. So this part that we are seeing here can also be given as n is equal to the cube root of hm, everything like this, to the exponent of 2, plus pt to the exponent of 3 like that. All right. So different ways of expressing your answers. And with this, you are now asked to calculate the value of n if we are given this information, h being 2,15, this and that. So that is, it's just a continuation from this. Remember, we already have n as the subject. It's up to you which condition are you going to use, okay? We already have the n. So in the simplification, yes, we can use this one, h squared, but in terms of the substitution, it'll be best for you to use this condition, like to combine hm together to the power of 2. So n is equal to the cube root of, so that's the cube root of hm. Remember, h is given as 2,15. So that's 2,15 times m, which is 2,5. So everything is raised to the power of 2. So I'm not saying to write it as the cube root of 2,15 to the power of 2 times 2,5 to the power is wrong. No, you can also write it like that. It is just one and the same thing. All right. So this is going to be plus p. Remember, p you are given there as 2. So that's 2 times t to the exponent of 3. So you can even open a bracket like this for t, which is 3. Remember, t was 3, but raised to the exponent of what? Of 3. So with this, you can simply use your calculator for the simplification to obtain the value of n. So let us see what we were going to have at the end. So that's the cube root of, all right, so this is the cube root, which is here. So that's shift on the square root. There's a cube root there. So just open a bracket, 2,15 times 2,5 raised to the power of 2 plus 2 times 3 to the exponent of 3, like that. So that was going to be 4,36 and so forth. And we can even round this to 3 decimal places. Remember, guys, that's the use of our calculators there. All right, that is, this one was 2,15. All right, 2,15 times 2 to the exponent. All right, plus, let me just also put a bracket here to verify this. Put a bracket also here. 3 times, I'm just going to also put a bracket, but that's one and the same thing there. All right, 4,36 and so on. So if you're to check, we can consider to 3 decimal place. That's on your calculator. Shift, let's go to the setup, fix this. Number 6, you're going to fix to 3 decimal places. So that's 4,30 in that case. So n is 4,360, 4,360, like that. Okay, so this is what you were going to obtain from our calculations. We just have to substitute the given values that you are having. So like I said before, even if you were to substitute these ones separately without having this whole part combined as the, all right, we can also have this part here as like this, the 2,15 squared on its own times the 2,5 squared on its own, like that. Still, you're going to obtain the same answer, all right? So it's not like combining that. I was just saying to combine, it can be just easier for you to see properly your calculations, but it's just one and the same thing. So I do not know how exactly you attempted these questions, but that is what you're supposed to have on question 1. Let us consider question 2. So question 1, it was actually 13 marks, okay, which is fine. Question 2, it was the simplification there. All right, 2.1, simplify the following algebraic fractions and factorize your answer completely. All right, meaning to say your answers are supposed to be in a factorized manner. In whatever way that you're going to have, your answers are supposed to be in a factorized manner. So I'm just going to start with 2.1. We are given 2.11. All right, let's consider our fractions there. So this is what I'm going to do. This one, I'm just going to answer it, guys, because we are given, remember, whenever you have got a division like this, you're going to introduce multiplication, then you invert the second fraction. Also here, there's a division, introduce a multiplication, then you invert the second fraction, that is, you interchange the fraction that follows after the sign. So meaning to say this part, I'm just going to rewrite as it is. All right, so that we can be together there. All right, so the first part, I'm just going to write it as it is, which is p squared plus 2p, everything over p squared minus 2p. All right, since there was a division, you introduce a multiplication. So there we are actually answering the question there. So you introduce a multiplication, and by introducing a multiplication, you interchange. So this will be written on top. This will be written in the denominator. So the p squared minus 4p, whatever that we have there, is going to be written on top. So we are going to have p squared minus 4p plus 4. Everything over what? Everything over p squared minus 4. You interchange. After that, you can also see that there's a multiplication, there's a division there. Introduce a multiplication, interchange. So this will be written on top after introducing the multiplication sign. So this is going to be times. We are going to have the p squared plus the 4p plus the 4, everything over 2p squared. We interchange that. 2p squared plus what? Plus 4p. So this is what you're going to have. We are already answered from that step. So you're supposed to have our question then is equal to, so there, I'm just going to start from there. Let's factorize and see. The first part, we're just given two terms, p squared. There's a p there, so you're just going to factor out the highest common factor, which is p. All right, so let's divide p squared and p, that will be p, plus 2p and p, that will give us a 2. Everything over p squared minus 2p is just the same thing, just that only that there's a negative there. So you're going to factor out p. You remain with the same part, p, but having minus 2. So this is what we're having there. Multiplied 2, you factorize this. As you can see, this is a direct factorization since the coefficient of p squared is 1. So remember that you can just have your two brackets here. So I'm just going to have two brackets. All right. So the first one, I'm going to have p, other one p. So what are the factors of 4? The products of 4, but they will add up to minus 4. So consider 2 times 2. It will give us a 4. But if you add, that's a positive 4. So to obtain a negative 4, this must be negative 2, negative 2. All right. So that's a minus 2, a minus 2. P squared minus 4, that's a difference of 2 squares. That's a perfect square, a perfect square. So remember your difference of 2 squares. The square root of p squared, it's p. P here. Then you're going to have minus the square root of 4, which is 2. The square root of 4, which is 2. Remember, the other bracket subtracts, another one adds from our difference of 2 squares. Times, we can see that this and this is exactly the same, only that there is a minus. Here there's a plus. Here there was a minus, here there's a plus. So it's simply these two brackets, they are going to remain as they are with a plus. We're going to have the same brackets, but only having a plus. P plus 2, P plus 2. Do not waste much time there. It is one and the same thing, just like what we had here. All right, 2p squared plus 4p. 2 and 4. 2 is the highest common factor, and we factor out p also. So that is 2p squared divided by 2p. As we can see, this will cancel, and you remain with p plus 4 and 2, which is 2. P and p cancel. So this is what you're going to have. After factorizing, we can now cancel the brackets as long it is the relationship between the numerator and the denominator like this. You can cancel. The numerator to the denominator can be cancelled. As long it is numerator to the denominator, you can cancel. As long they are the same, you're considering this and this, they are the same from the numerator and the denominator, they can be cancelled. P minus 2, P minus 2. We've got P plus 2 here, P plus 2 here. Okay, let's move on. P plus 2 here, P plus 2 here. As we can see, we have cancelled all brackets and all terms which were outside the brackets. We are just remaining with the P plus 2 on the numerator, which cannot be cancelled, with the 2p in the denominator. These two cannot be cancelled. So we are just going to leave it like that. You're done. So that is what you're supposed to obtain in this case. Considering the same situation happening on question 2.12, but this one is for the simplification of subtraction of fractions, this and that. All right, let's see what we are given them. Let's just take, in this case, I'm just gonna factorize it straight forward. Our denominators, since you can see that rewriting, guys, is gonna be something else. So this was going to be 2r minus 1, everything over. We have to consider our denominator there. Factorizing of the denominators. Remember, factorization, guys, is something that you are supposed to actually consider, and I'm sure by now you have got different ways of your factorization techniques, which you do understand, all right? So since the coefficient of r squared is not a 1, I'm just going to use the last concept that we applied of multiplying the first term to the last term. So if I multiply 6r squared and 20, that will be 120 r squared. Do we have two terms that we can multiply to obtain 120? And if we add them, we must obtain a negative 23. We have terms like that. Okay, let's think of the 15 and 8. Something there. 15 and 8. All right, just gonna take my calculator back to the normal mode. So that's shift. Go back to 8, normal mode, press 2. Okay, I'm having two numbers that I was asking that are they going to help us, these two numbers? 15 times 8, we get positive 120. And if we add these two, we obtain a positive 23. So to obtain a negative 23, it means we are supposed to introduce a negative on these numbers. A negative 15 and negative 8. All right, so that's it. Let's factorize. Remember, I said you are going to take these into the middle term as they are. Minus 15r minus 8r as it is plus 20. Okay, so let's consider. There we have got, okay, let's see. 3r is common in these two terms. We can factor out 3r in this case. 3r, then 3 and 6 and 3, that's 2. R minus 15. Okay, minus 5 there. 15 and 3 is going to be 5. Okay, there we've got minus 8 and 20. Consider 8 and 20 minus 4 can be the highest common factor there, so that you obtain the same bracket. Minus 8 and minus 4 was going to be positive 2. Okay, minus, minus. Positive, negative, that's a negative. It's going to be negative 5. So as you can see, guys, the two brackets are the same. So we are going to factor out the common bracket 2r minus 5. We remain with 3r minus 4. So this is what we are going to obtain from this denominator, these two brackets. So we are having 2r minus 5 into 3r minus 4. All right, we are done there. Let's do the same thing in our simplification. Let's apply the same concept in this next fraction. So there's a minus there. So that's r plus 2. Everything over what? You factorize again. So that's we have to consider. There we have got 2r squared minus r minus 10. So if you multiply the first term and last term, that was going to be minus 20 r squared. Do we have two terms that we multiply to obtain minus 20 r squared? But if we add, we must obtain the middle term, minus 20. There's so many numbers, 5 and 4. Because there's a negative here, one of these numbers must be negative. So let's put minus 5. And on the other one, let's put a minus 4. Okay? Which one now that when we add, we are going to obtain a negative 1. Minus 5 plus 4, that's a negative 1. So this is the one that we want. We just have to put r there. So these are the two that we are going to need. So it's going to be 2r squared. All right. Since here we can see that 2 corresponds with a 4, I'm just going to start with a 4 there. So I'm just going to have 4r minus 5r. I'm not saying it's wrong to start with minus 5r there. Still, it's one and the same thing. So grouping into 2, we can say that 2r is common between these two. So it's 2r into divide. That will be r plus 4 and 2. That will be 2. Minus 5 is common here. So you're going to have r plus 2. So these two brackets are common. So definitely we are going to take the common bracket, factor it out, which is going to have r plus 2 remaining with 2r minus 5 in another bracket. So we are going to have 2r minus 5 in another bracket. All right. You do the same thing, guys. In this simplification, we are going to do the same thing here. Minus, we have got r plus 2. So that's r plus 2 there over this bracket, this part that we need to factorize again. So we've got 3r squared plus 2r minus 8. Multiply these two, that will be minus 24r squared. Do we have two terms that we multiply to obtain negative 24? But if we add, we must get a positive 2. Yes, let's think of 6 and a 4, but one of these must be negative. So which one? Is it going to be negative 6 or is it going to be a negative 4? So if you add here, you're going to obtain a negative 2. If you add here, you're going to obtain a positive 2. So these are the ones that you want, the 6r and the minus 4. So meaning to say, we need 6 and minus 4 there. So it's going to be 3r squared plus 6r minus 4r minus 8. With these factors, we can group them into 2. Factor out what is common here, which is 3r. 3 and 3, that was going to be r plus 2. There we have got minus 4, which is common, which is going to be r plus 2. Okay, the two brackets there, as we can see, guys, they are the same. So we are going to have the bracket of r plus 2 into what is remaining here, which is 3r minus 4, like this. All right, so as we can see, like I said, the factorization, it's in your hands. Which way are you going to apply? That's why I just rushed there, because you can consider so many ways of your choice. But after factorizing, I want you to see something. It's true that it's under a subtraction. But are we seeing that there are some of these brackets which are exactly the same? We've got r plus 2 here, which is the same as this one, r plus 2. I said, on a as long as it's a single fraction, you can reduce your fractions. As long as it's a single fraction, x over 2x, you can reduce this and obtain 1 over 2. So it's the same, r plus 2 and r plus 2 can cancel. You remain with 1 over this. The same r plus 2 can cancel. You remain with 1 over 3r minus 4. If it is possible to do that, do it. Cancel these brackets. It's possible on a single fraction. You cancel here. That's a single fraction. Here it's a single fraction. So meaning to say at the end, you're going to obtain 2r minus 1 over 2r minus 5 into 3r minus 4 minus 1 over 2r minus 5 minus, there we canceled everything. So we've got 1 there. So it's going to be 1 over this 3r minus 4. So we have got a normal fraction that we are used to. So remember, simplification of addition, subtraction. We have to find the LCD or the LCM that we are going to maintain throughout. So what is going to be the LCD of these denominators, or the LCM? We have got 2r minus 5. We also have 2r minus 5 here. So this one is just going to be written once. You do not repeat this. So we've got 2r minus 5. We have got 3r minus 4. We also have 3r minus 4. So we are not going to repeat this. We just write it once. So this is our LCM, or our LCD. So remember the concept, you divide the LCD to the denominator here. So if you divide this into this, are we seeing that these are exactly the same? So they will cancel, you remain with a 1. So you're going to have 1 into 2r minus 1, which is our numerator. Minus, you do the same thing. Your LCD divides this denominator. So as we can see, the 2r minus 5 and the 2r minus 5 was going to cancel, meaning to say you were going to remain with 3r minus 4. But you do not cancel. You just imagine canceling, but you do not cancel. So you're going to remain with what? Minus 1, this one on top. Remember, there's a minus 1 there on top, into the bracket here that is remaining of 3r minus 4, since these two are going to cancel. Minus, we also have a -1 there. We do the same thing, our LCD to the denominator. All right, so this 3r minus 4, 3r minus 4 is going to cancel. You remain with what? 2r minus 5. This is what you're going to remain with. So this is going to be 2r minus 5, like that. So this is where we are. We are going to expand our brackets, collect the like terms. So 1 times anything, guys, remains as it is. So it's going to be 2r minus 1. Minus 1 times 3r, that's minus 3r. Minus 1 and minus 4, that's a positive 4. Minus 1 and 2, that's minus 2r. Minus 1 and minus 5, that's a positive 5. Everything over the LCD. You do not ignore that. Remember, I said you imagine as if you are canceling. You do not cancel it. You just imagine as if you are removing that part. So if you have to consider there the 2r and the 2r, going to subtract, you remain with minus 3r there. So that's minus 3r. Let's consider the numbers together. 4 plus 5, which is 9, minus 1, which is 8. All right, so that will be positive 8. Okay, so you're going to have a positive 8, or you can just use your calculator there. Everything over the LCD as it is. Remember, this does not change. So it's 2r minus 5, 3r minus 4. Unless there is a common part where the numerator is exactly the same with one of these brackets in the denominators, where it is like that, you can cancel. But here it does not exist. So meaning to say, this fraction is done. You can maybe start writing this as with a positive 8, like 8 minus 3r, like this, everything over 2r minus 5, 3r minus 4. That is the only thing that maybe you can do. Not to cancel. There's nothing that you can cancel. There's nothing that is common. You are done like that. So this is what we had. And as I said, you were supposed to just factorize, then simplify from there. You would obtain that. 2.2, given the following algebraic expressions, these two expressions. 2.21, factorize each expression completely. Each. Let's start with the 24, xy minus 9x squared y squared. Do we have anything common here between the numbers 24 and 9? Thus 3 is common there. You can factor out 3. Between 24 and 9, there is 3. All right. So considering the part of xy, this is xy, this is xy squared. So remember, the highest common factor is the one that has got the smallest exponent. So we are going to take 3xy into the bracket. Let's see what are we going to have if we divide 24xy divided to 3xy. You are going to obtain 8. The xy and the xy was going to cancel. So meaning to say you remain with 8. You just imagine as if you are canceling there. So that's 8 minus 9 and 3. That was going to be 3. X squared to x, y squared to y. It was going to be like this. All right. So that's where factorize the first part. Considering the second part, this is 256 minus 36 x squared y squared. So the question is, between these two numbers, do you have a highest common factor here between these two numbers, 256 and 36? The highest number that you can factor out there is a 4. They are perfect squares, which is fine. So you can actually use your difference of 2 squares, but you can also factor out the 4. Let's divide 256 divided by 4. That is 64. 36 divided by 4. That is 9. So as you can see, these two numbers, 4 can be factored out. All right, so we can factor out 4 first. Whereas the highest common factor, remember the golden rule, always start with the highest common factor. So 4 is the highest common factor. 256 divided by 4, we saw that it was going to give us 64 minus 36 divided by 4, which is 9. So that will be minus 9 x squared y squared like this. But look, this here is a difference of 2 squares, still a difference of 2 squares because these are perfect squares. 64 is a perfect square. Its square root is 8. So remember the concept of our difference of 2 squares. One subtracts, another one adds. The square root of 9, which is 3. The square root of x squared, which is x. The square root of y squared, which is y. So this was just going to be 3xy on the other hand. So that's a difference of 2 squares. Obtain the square roots. So we have factorized the first part. This is what we obtained. The second part, this is what you're going to have as your final answer. So just in case maybe you did not realize that 4 is common there, you just considered, all right, there's a difference of 2 squares, which is actually fine because you can see that that's a difference of 2 squares. 256 is a perfect square. We have its square root. We can obtain the square root of 256. Okay, let's use our calculators here. I want you to say something. Maybe you made that calculation. Sorry, the square root of 256. Here is what? 16. Meaning to say it's a perfect square. So this is a difference of 2 squares again, where the square root of 256 is 16. Minus the square root of 36, which is 6. The square root of this, guys, is going to be xy. Remember the concept. Another bracket will add. So it will be 16 plus 6xy like this. Another bracket will add. But this is not completely factorized. We have factorized, but not completely, because we can see that in each of these brackets, this bracket, there's a highest common factor again. This bracket, we still have a common factor. So you are not yet done when it is like this. You are supposed to factor it out again. Between 16 and 6, 2 is common. So you're going to factor out 2. 16 divided by 2, which is 8 minus 3xy. So this is what you're going to do if you factor it out this way. You move on to this bracket. What is common? Again, 2 is common. In this is a separate, guys, this is a bracket on its own. This one is a bracket on its own. So you factor out 2 again from this bracket. What are you going to remain with? 8 plus 3xy. So these numbers are outside of the brackets. The 2 and the 2, they're outside of the bracket. They can be multiplied. 2 times 2, which is 4, into the brackets that we are having. 3xy into 8 plus 3xy. That is in case you considered the difference of 2 squares first. Still, you're going to have the same answers, but you could have factored the highest common factor first, then you apply your difference of 2 squares, just like this. As you can see, it was going to be easier to work with from this consideration. So after this 2.22, it was now to determine the highest common factor, which is HCF, and the lowest common multiple, which is the least common multiple for these two expressions. So it is just a continuation that we are going to have. Remember, the highest common factor, it is supposed to be common, a factor that is common throughout. We see it here. We also see it here in this one that is factorized. So outside of the brackets, do we have a highest common factor? No. There's a 3, there's a 4. There's xy here. We do not have that. So there is nothing. We move on to the terms inside of the brackets. There is 8 minus 3xy here. There's also 8 minus 3xy. That's a highest common factor. It's common throughout. 8 plus 3y, we do not have it this side. So it's not a highest common factor. So this is what's going to be our highest common factor. Then the least common multiple, which is the lowest common multiple in this case, the LCM. I said you take everything that you see, everything. So outside the brackets, we've got 3 and 4. So let's multiply 3 times 4. Everything as it is, 3 times 4, xy, the bracket of 8 minus 3xy as it is common here, so we're just going to write it once. Also the bracket of 8 plus 3xy, everything as it is must be considered. So 3 times 4 times xy is just going to give us what? 12xy. So that was going to be 3 times 4, which is 12xy. That's our LCM. Everything must be taken. Everything that we are seeing must be taken. So that is what we're supposed to do in this question. That is actually question 2. Question 2 is done. Okay, let's move on to another part. So number 3, we are given 3.1. Okay, let's see what you're given there. The log of 2 is m, and the log of 7 is n. Calculate the following, leaving the answers in terms of m and n. So we need the answers in terms of m and n. So take note, your calculators, guys, they are not going to work because this is it. Your calculator does not even know this m over n. It can just simplify direct. This is your calculator. It gives you the exact value. But here we do not want this exact value. No. We want our answers to be in terms of m and n. So we are supposed to use in as much as we can this information that we are given in terms of m and n. What consists? Where is m in log 2? Where is n in log 7? So meaning to say wherever we see a log 2, we are going to substitute an m. All right, so let's start with the first question, 3.11. The log of 2 over 7. Okay, let's consider our laws since this here is a division of numbers. Where was this taken from? Remember the logarithm of a over b from our laws of logarithms. It is taken as log a minus the logarithm of b as long the bases are the same. You're going to subtract. So we are going to subtract these two, meaning to say this is going to be given as the logarithm of 2 minus the logarithm of a 7, just like log a minus log b. As we can see, guys, here, there we do not have log 2. So you do not write it as m over, this is wrong. This is wrong because this is not log 2 over log. If it was like this, it was just going to be direct. I substitute log 2, which is m, log 7. There, we're not going to calculate anything. Take note. This one is log 2 over 7. It's a combined part. So you separate. Now that you can see properly, this is your log 2. What is it that represents log 2? It's m. Minus, what is it that represents log 7? It's n. You substitute that. So this is what we're going to have, guys, as log 2 over what? As log 2 over 7. It was going to give us m minus n. All right, let's consider another question, which is 3.12. On 3.12, we can see that totally we do not have these numbers, the 2 and the 7. On the first question, there was 2 and the 7. Even if it was like this, maybe you are given direct log 2 times 7. They gave you. You can see, okay, it's a product there. I'm just going to add the logarithms log 2 plus log 7. You are seeing the 7 and the 2 there. But here we cannot even see the 2, the 7. So what are we going to do? Do not worry. Check the number that you are given, express it as a product of its prime factors so that you can properly see the numbers which are into this 196. So let's start with the 2. So if we divide 196 divided by 2, you can also use your calculator if you are someone who is not into these divisions. Okay, since some of us guys are not into divisions, use calculators if you're like that. All right, so that's 196 divided by 2. That will be 98. So you're going to obtain 98. As we can see, we can also divide by 2 again. 98 divided by 2, that was going to be 49. So as you can see, this time we cannot divide by 2 because this will give us a decimal. Okay, so this is not exact. So which number are we going to use in 49? That's a 7. 49, we can use a 7 there. If we divide 49 and 7, that will be a 7. 49 divided by 7, that's a 7. Again, by 7, that's a 1. So as we can see, as a product of prime factors, 198 can be written as 2 times 2 times 7 times 7. So meaning to say we can also write this in the way that we do understand. This here can be written as log of these numbers, 2 times 2 times. This is what we have. So remember, 2 times 2 is same as 2 squared. Okay, but if you do not understand this, guys, just write as 2 times 2. Do not worry. 2 times 2, 7 times 7. Maybe you do not understand this, just write it like that. So just note that everything is under multiplication. It's no longer a division like what we had here. The multiplication of A and B, it was because the logarithms were being added together. So we are going to add these logarithms. The logarithm of 2 plus the logarithm of 2 plus the logarithm of 7 plus the logarithm of 7. So there we have these logarithms. In place of these, we can substitute log 2, it's what? It's m. Plus log 2, it's what? It's m. Plus log 7, it's n. Plus log 7, it's n. So let's add m plus m. That's 2m plus n plus n. That's 2n. So this is what you're going to have in terms of m and n. You can even factor out the 2. It's in your hands. This one, it's up to you guys. You can even leave it at this stage. It's one and the same thing. That is what we had. Let's say you used this part of raising to the power of 2. How were you going to simplify it if you use the power of 2 in this case? It was going to be written as log 2 to the power of 2 times 7 times 7. That's also 7 to the power of 2. Okay. Remember, it's a product. So we are going to add. That is the logarithm of this term, 2 to the power of 2, plus the logarithm of this one, which is 7 to the power of 2. There we have got exponents. We need to see the log 2, not raised to any power, not the log 2 as it is. So what is it that we are going to do? Is there a law that we can get rid of this 2 on the power, this one? Yes, remember that if you are given n logarithm, or you can just take it like this, logarithm of a to the exponent of n. If you're given an exponent like that, the exponent multiplies the logarithm. So that's n log a. The n multiplies the log. So meaning say the 2 multiplies the log. So this was going to be 2 log 2 plus the same thing, drop the exponent. So that's 2 log of 7. Now we can properly see these logarithms that we need, the log 2 here and the log 7. So let us just substitute exactly what represents these logarithms. Log 2 is represented by m. So in place of the log 2, we are going to substitute m. In place of the log 7, we are going to substitute n. So as we can see, that is exactly what we had. The simplification might differ, but you're supposed to obtain one and the same thing in that case. All right, so that was our question 3.12. Let us consider Question 3.2, simplify the following without using a calculator. Definitely, there's no way you can use a calculator on this one, where we are given this. Maybe on 3.22, that's where it can apply. All right, so the first part, remember that when you are working with the bases which are the same, in this case, when you're multiplying and the bases are the same, you simply add the exponents. So meaning to say there, we're simply going to add t. You take this as it is, that is 3u minus v minus 2w. Then we add to this one. So it's going to be plus 5u minus 4w like this. But remember, when you are dividing, you're supposed to subtract. So you're going to subtract the part that we are given here as it is. So you're just going to open a bracket for this. That's u minus 6v minus 3w like this. All right. So this is what we're going to have. We can even expand the brackets, collect like terms here before that, which is important. So let's collect like terms 3u and 5u. That is going to be 8u minus v. And okay, there is only minus v there. So just going to be minus v. Let's move on to w. There is minus 2w here, minus 4w here, which is going to be minus 6w. Then expand the brackets. This is negative 1 times u, which is negative u. Negative 1 times 6, that will be a positive 6v. Negative and negative 3, that will be a positive 3w like that. So this was going to give us what? If collect like terms again, 8u and u here, this is 1. So it's 8 minus 1, which is 7. So we're going to obtain 7u. The part of v, there's a v here. There's also a v here. So this is minus 1 plus 6, which is 5. So we're going to obtain 5v. The part of w, there's a minus 6w here and a 3w here. So minus 6 plus 3, that is minus 3w in that case. So as we can see, this cannot be simplified further. We're done. There's nothing that we can do here. There's nothing, we cannot simplify anything from this part. So we're just going to leave our answer at this stage. All right. Then 3.22, you're given 3 marks for that, a logarithm. That is the logarithm, okay, of 8, the square root of 8. Remember, the square root means to the exponent of a half. So this is 8 to the exponent of a half, to the exponent of a half in base of 2, minus the logarithm of exactly the same thing, 27 to the exponent of a half in the base of 3. Remember, in our logarithms, we can write this in the same way, the 2 and the 8. So 8 in the base of 2 is 2 to the exponent of 3. But already it's raised to the exponent of a half. Already there's an exponent of a half there. So meaning to say this was going to be 2 to the exponent of 3 over 2. So this is the logarithm of 2 raised to the exponent of 3 over 2 in the base of 2. Minus the same thing on this 27. It can be written in the base of 3, which is 3 to the exponent of what to give us a 27 to the exponent of a 3. But already it's raised to the exponent of a half there. So that will be 3 to the exponent of 3 over 2. Just multiply 3 times a half. So that's log 27 is the same as log 3. Log 27 to the exponent of a half, is same as 3 to the exponent of 3 over 2 in the base of 3. Remember, I talked about a condition where the exponent is involved, like this one, where we can drop our exponent. So we can simply drop our exponent here. Drop our exponent here. So that will be 3 over 2 at the logarithm of 2 in the base of 2. Do the same thing here. That will be minus 3 over 2, the logarithm of 3 in the base of 3. So now let us consider this condition here that is on our logarithms. We do understand that a number under a logarithm, when these are the same, the log of a in the base of a is equal to 1. So this is exactly what we are seeing here. This is exactly that we are seeing also here. That means we're going to have a 1, a 1. So that means we are going to have 3 over 2 times 1, which is 3 over 2, minus 3 over 2 times 1, which is simply 3 over 2. And subtracting these two are the same. That was going to give us what? A 0. So that is what we are supposed to obtain. And we can also prove this on our calculator. Are we going to obtain a 0 in that case? All right, so let us take this one. That is the logarithm in the base of 2. So take note, this is in the base of 2. And we've got the square root of 8. All right, minus, we're going to have the logarithm in the base of 3 of the square root of 27, like this. So as we can see, that was going to give us a 0 there, which is exactly the same answer. That is, use your calculator to prove. Are you having the same answers as what you're supposed to obtain if you were just simplifying direct? All right, so that was it then for 3 marks, which is fine. Then 3.3, 4 marks. Solve for x using the laws of exponents. So we need to apply some laws of exponents there. All right, so let's see what we can do on this one. That's 3.3. All right, so if you're to consider there, we can use our laws of exponents. Remember, if you're given something of this nature, let's say, let me write it this way so that we understand each other. X raised to the exponent of m over n is given as the nth root of x to the exponent of m. So we're just going to have a reverse. All right, just going to have a reverse in this case. So meaning say this will be x, the exponent m over n, m over n. So that is 3 over 4. So this is 3 over 4. Everything over what? Let's say there we've got the square root. But inside this square root, we can see that there is an exponent of a 0 there. So the square root of 8 raised to the exponent of a 0 is 1. So we are going to have 1 times 2x, which is 2x. So this was going to be the square root of 14x plus 2x, because it was going to be 2x times 1. This whole part raised to the power of 0, it's what? It's 1. So it was going to be 2x like that. 2x times 1, which is 1, is equal to 3 over 4. All right, this is where we are. Stage by stage. There we are given, this is just going to be, let's add 14 plus 2 there, which is 16. So you're going to have 16x. But remember, there's a square root there. So it means we are having the square root of 16x. All right? Which is going to give us what? 3 over 4. Okay? Let's leave it like that. Guys, we know the square root of 16. We do know this. We do know the square root of 16 is what? It's 4. So meaning to say we're going to have x to the exponent of 3 over 4 over like this. This is what you're supposed to have. I want you to see exactly what you're supposed to have. We have got the square root of 16x like this. We can obtain the square root of 16, which is 4. But the question is, can we obtain the square root of x? No, we can't obtain the square root of x. So it will remain under the square root, where we do understand that from our laws of exponents, the square root of x means x to the exponent of a half. So meaning to say this part that we are seeing, we could have written this as 4x to the exponent of a half, simplifying this square root of 16x here. All right, so this is equal to 3 over 4. This is where we are. These two terms, guys, as we can see, they have the same base, x. And we do understand same bases when being divided, we can subtract the exponents. So meaning to say that will be x to the exponent of 3 over 4 minus 1 over 2. We are going to subtract the exponent of 1 over 2, and that will give us 1 over 4. Everything over what? Over 4. Remember, the 4 there is still there. Everything over 4 is equal to 3 over 4. So there we applied the laws of exponents. You are dividing same bases, subtract the exponents. We want to calculate x, guys. There is a 4 here that is disturbing in the denominator. There's also a 4 here. So simply I can just multiply by 4 like this, so that this can cancel, this can cancel. So I'm left with x to the exponent of 1 over 4, which is equal to 3. Guys, at this stage, you must have the side of where this is going. This is a question that you can actually be asked. They can even ask you a question like this. X to the exponent of 3 over 2 is equal to find x. Remember that concept of finding the reciprocal of the exponent, 1 over 4. What is the reciprocal? You interchange. That's 4 over 1. So you raise this to the exponent of 4 over 1, which is 4. You also raise this to the exponent of what? 4 over 1. So that this will cancel, guys. Remember, a number times its reciprocal gives us a 1. So this will be x to the exponent of 1 equal to 3 to the exponent of 4, which is 81. So x is equal to what? To 81. You can also prove this by substituting into your equation, guys, the value of x that you just calculated, and see if it is going to make sense. All right, so this is what you were supposed to just have done. I don't know which way did you apply, guys, but you must have the same value of x. All right, so question 4. Let us quickly have this. Question 4. 4.1, we are given the surface area of a right cone. Thus, we are having a right cone is, all right, that's a right cone. We are given the surface area of a right cone. Okay, that's... Remember, a cone is just like this. A right cone is just going to be of this nature, where we have got a circle here, and we're going to have a radius taken to the perpendicular height. So this is the perpendicular height joining to the radius. At the center there, we're going to have the radius, the perpendicular height, the slant height. So we are given the surface area in this case, which is the surface area of the right cone is 250 pi square centimeters. So this is 250 pi square centimeters. And we are also given that the base radius of the cone is 5 centimeters. We have got the base radius, this one, the base radius is 5 centimeters. Thus, we have got the radius here, 5 centimeters. So the question was, from this information, 4.11, calculate the following: the perpendicular height of the cone. The perpendicular height of the cone. You have the surface area in this case. This is the only thing that you can think of from what we are given. We need to calculate the perpendicular height. We only have the surface area and the radius. So let us consider what is it that we have on from our formula sheet. So I want us to consider our formula sheet as well, so that we can also understand our formulas there. So from our formula sheet, remember, this is what we have on a right cone. All right, on a right cone, there are two formulas there to use for the surface area. There is this formula that we are seeing. It has, let us consider this formula. It is written in terms of the radius and the height, radius and height. The second formula is written in terms of what? It is written in terms of the radius, the length, which is the slant height, and also that is the radius and the slant height that we have in this case. Only these two, radius and the slant height. There it's radius and the perpendicular height. So which formula is best to use? Can we use the second one? No. Because we need to calculate the height. So we are going to consider the first formula in that case, all right? So using our first formula, let us see how can we apply our formula. It is given as the surface area. So I'm just gonna write it in short. So the surface area of a right cone is given as pi r. So we are given this as pi r into the square root of h squared plus r squared. All right. Then we are going to have plus pi r squared. We have this formula. All right. So that is the best formula for us to use since we want to calculate h. So let's substitute surface area. That is 250 pi is equal to pi times the radius. Remember the radius there is 5 times the square root of h squared plus the radius squared. Remember the radius is 5. So that will be 5 squared. Okay, we are substituting everything plus pi times radius squared. Radius is 5, so it's 5 squared. All right, so let's just try to simplify before we simplify further. Let's just try to rewrite this in a simplified version. 5 times pi, that is 5 pi the square root of 5 squared, which is 5 times 5, that is 25, plus h squared, okay, plus 5 squared, which is 25 pi. Okay, here you can even write as h squared plus 25 does not affect. So I want you to see that this term here can be taken to the left-hand side since it's a like term here. So it's going to be 250 pi minus 25 pi. So guys, just subtract there on your calculator straightforward. That's 25, 250 minus 25 like this. Okay, let me just show you guys. 250 minus 25. So this will give us 225 pi. So it's 225 having pi. So it's 225 pi. We subtracted this. So this is equal to 5 pi, the square root of h squared plus 25, which is same as 25 plus h squared. So we can divide, guys, both sides by this 5 pi that we are seeing here, by 5 pi, both sides. Since it's a multiplication, the pi and the pi was going to cancel. So on your calculator, it's now 225, which is supposed to be divided by 5. And that was going to give us what? 45. So we are going to have a 45 after this. So that's 45 is equal to the square root of 25 plus h squared. Thus, we've divided this. So the question is, how are we going to solve for h? And it's like we are making h the subject. That's to solve for h. It's under the square root. Now we can think of removing the square root. Remember to remove the square root raised to the power of 2. That means we are having 45 squared is equal to this. So what is our 45 squared in that case? If you raise 45 to the power of 2, that was going to be 2025. So 2025 is equal to, have removed this square root, so it's 25 plus h squared. All right, you want to solve for h, let's take the 25, the other hand, it will be a minus. So we are going to subtract 225, we subtract the 25, it was going to give us a 2000 there. So 2000 is equal to h squared. So you can introduce the square root to remove the square that we are given. So the h was going to give us the square root of 2000, which is going to be what? Let's just consider the square root of 2000. That's 20 square root of 2, which is 40. Now we can also fix this to 3 decimal places. which will be 44,721. So that's 44,721. So that is the value of h that we are going to have at the end by solving this equation that we are given there. So we need to be very, very careful in our simplifications. We need to be very, very careful in our simplifications. All right, having the height, let us consider the other question. Now it was to calculate 4.12, the slant height of the cone. So remember, the slant height of the cone is this L that we are seeing here. And we can see that we have got a right-angled triangle that is being formulated there. So we can use the height that we calculated and the radius that we are given to calculate the slant height, because we are forming what? A right-angled triangle from this. We are having something of this nature, a right-angled triangle here. So this is our radius, which is 5. And the perpendicular height that we calculated, that was 44,721. So we have got 44,721. So with this, we can calculate the slant height, which is L. So using our Pythagoras theorem, remember this is our h and this is our radius. So it follows that L squared is supposed to be h squared plus r squared, or r squared plus h squared. So you can even introduce the square root here. That means L is equal to the square root of h squared plus r squared. So thus we can just substitute what we calculated in this case. So it's going to be the square root of h, which is 44,721 squared, plus the radius squared, which is 5 squared. So on your calculator, simplify this already. If you are to consider, our calculator is already fixed to 3 decimal places. So meaning to say, whatever that we are going to obtain will be to 3 decimal places. So this is the square root of 44,721 squared plus 5 squared. So that's 45,00 and so on. So that was simply going to be 45, all right, and centimeters. So that is, we have got the slant height in this case, all right? The slant height is there, 45,00 and so on. All right, let's see. Another part, it was now the volume of the cone. So also you can consider the volume of the cone. We have got from our formula sheet, again, we are given the formulas for this one. So you can also just consider this, the volume of a cone, given as a third pi r squared h. So meaning to say, we can use the formula straightforward there. We have got everything. We calculated the height. Remember, the height, we calculated this. So that was going to give us the volume. So the volume, as we are given, that is a third pi r squared h. So meaning to say, it's just substituting a third times pi times the radius squared, which is 5 squared, times the height, which is 44,721. So this was going to give us the value representing our volume. With our calculator fixed, it's just going to give us our answer to 3 decimal places, in this case, times pi times 5 squared times 44,721, like this. So that was going to be as a decimal 1,170, now 793. So the 793, this is volume measured in cubic units. So it is going to be in cubic centimeters in that case. So we can consider our volume, that is a third pi r squared h from what we are having. That is, we can have this, then it was just a matter of what? Of substituting our values in that case, a matter of substituting in this case. All right, let us consider 4.2. 4.2, we are given the area enclosed by a curve that passes through the points. So remember, these are the points that you'll be given in terms of x and y, and so forth. So we are given the area is 144 square units. Calculate the value of x. How do you calculate the area? That is the question. When you are given this part from our mid-ordinate rule, how do we calculate the area? Okay, let's get back to our formula sheet here. So we do understand that the area is taken from this formula, which we can take it as from the first ordinate plus last ordinate over 2 plus sum of other ordinates times the distance between. All right. So understanding this formula is going to help us to answer the question that we are given there, because already we have the area. So if this area of 144 was equal to the sum of the first and last, which one are we considering as the first and last ordinates? In this case, we are given these as points. Remember, these are points. So the ordinates we are talking about, the y values, like they separate from here, 1 over 2, 5 over 2, 7 over 2, 13 over 2, x over 2. These are the ordinates that we are talking about. So we are going to consider the first, which is 1 over 2. So remember, it's first plus the last, which is 3 over 2. Everything divided by 2. Okay, that's our formula. Then what are we going to do? We are going to add the remaining ordinates as they are all the remaining. The remaining one, all of these. So we are remaining with what? 5 over 2. So we are going to add 5 over 2 plus 7 over 2 plus 13 over 2 plus x over 2 plus x minus 4 over 2. So as we can see, we are forming an equation by doing this. 11 over 2. These are the remaining ordinates. We add all of these remaining ordinates. Then we multiply by the distance between the ordinates. The distance between the ordinates is the one that you take from the x values from 0 to 6 to 12 to 18 to 24 to 30 to 36. There's a difference there of 6. The difference of 6. The difference of 6 from the x values. That is the distance between the ordinates of 6. So as we can see, this is an equation that you are supposed to use to solve for x. But how? That is the question. All right, let's just try to simplify stage by stage. We can consider the 6 that we are given here. It's a multiplication. Remember this one. So you can just divide by this 6. All right, just divide by this 6 here to remove this 6. So just simply divide by 6 so that you remove this 6. 144 divided by 6. So there we have to divide 144 divided by 6, which was going to give you a 24. So 24 is equal to, you simplify this on your calculator. So that was going to give us a 1 there. All right, let's just have our calculators, guys, for the sake of understanding this. So remember, our calculator was fixed. So you have to put back your calculator to the normal mode. Remember, it's fixed there. So it's going to be shift normal, then press 2 there. All right, let's put a fraction. 1 over 2 plus, that's 1 over 2 plus 3 over 2 plus 3 over 2 like this. Everything divide it by 2. So that was going to give us a 1. All right, so this was going to give us a 1. So how are we going to simplify inside the bracket? Just add this part, 5 over 2, 7 over 2, 13 over 2, the 11 over 2. Add everything that we are seeing there. 5 over 2 plus 7 over 2. All right. 7 over 2 like this. Or another way to avoid confusion here. Okay, let me just finish up. Plus, we added 7 over 2, then 13 over 2 like this, plus 11 over 2. Just add all these ones where x is not there. This was going to give us 18. So if we add all these numbers, we were going to obtain what? 18. But as we can see, we have a part that is remaining with x here that we haven't added. So we must combine the remaining part here in terms of x that is remaining here. So let's consider this, guys. If we can see that the denominators are the same, so remember, if these two are the same, you simply have to add the numerators. So it was going to be x plus x minus 4, everything over 2, where x plus x is what? It's 2x. So this was going to be plus 2x minus what? Minus 4 over 2. You are simplifying the part of x on its own if you are to do it like this. All right? So this is what you're going to do. Actually, there's no need for a bracket because we removed the 6 here that was outside of the bracket. Remember, we divided it here, so we no longer need the bracket there. So this is what you're going to have. From these two terms that were being added, divided by 2, we get a 1. From these other remaining terms, we add them, we obtain 18. Then the part of x on its own was going to give us 2x minus 4 over 2, of which this can be simplified, guys. 2x minus 4 over 2. We can simplify this. It's 2x over 2 minus 4 over 2. So this and this can cancel. We've got x minus what? Minus 2. So instead, we can write this as x minus 2. So 24 is equal to 1 plus 18, which is 19, plus this part separated, which is x minus 2. So 24 is equal to 19 minus 2, which is 17 plus x. All right, let's find x. Take the 17 to the other hand so that it will subtract. So that's 24 minus 17. So the difference there, it will be the value of x, which is going to give us a 7. So meaning to say 7 is equal to x. That is the whole part that we're supposed to have done. So on the solving thereafter, it's in your hands. What is important is that the equation, you formed it. That is the most important. You formed your equation. The solving part there later on is actually in your hands. How are you going to solve your equation? The simplification inside of the brackets. So this is what you were supposed to obtain on this question 4.2. Let's consider another part of our question, which was question 5. And there we have got 5.1. Given the functions, we are given a function of f of x. Determine the y-intercept of the function. Okay, this is something that we can consider direct here. Remember, the y-intercept x is supposed to be equal to 0. So if x is equal to 0, you can substitute as 0 here. You're going to see that y was going to be what? A negative 9. So that's 0 minus 9 as a point, if you want to write as a point. 5.12, the roots of the function. So the roots of this function are the x values when you solve this equation. 5.12, remember the roots are at a condition where f of x is equal to 0. Y is supposed to be equal to 0. So this whole equation minus x squared plus 6x minus 9 must be equal to 0. So you solve. It's an equation. We can divide by, to remove this negative, we can remove this by dividing by negative 1. So that you do not have confusion there. So that's x squared plus minus 6x minus plus 9 is equal to 0. Guys, we can even factorize this. Remember the products concept. Okay, since we have got x and x here, the products of 9, but these products must add up to negative 6, negative 3, and negative 3. Multiply this, that's a positive 9. If you add, you get a negative 3. So that's negative 3, negative 3. So as we can see, we're obtaining same values of x. X is equal to 3 or x is equal to 3. So the roots of this function are at a same point where x is equal to 3. So it means that point where x is 3 is also a turning point, depending with the shape that we are going to have. But it follows that it's going to be a turning point. That is what it means. All right. We're going to see that when sketching this. Then 5.13, the axis of symmetry of the function. So the axis of symmetry, it will be like this when, since this is a solution, remember, and it's also a turning point. So that is where the axis of symmetry is also obtained. So meaning to say, for the axis of symmetry, x is simply equal to 3. If you understand this, you're just going to write this direct, x is equal to 3. But let's say you do not understand this. What are you going to do? Remember, for the axis of symmetry, you have these formulas, all right, from our formula sheet here. We do understand that the axis of symmetry can be taken from minus b over 2a if we are having a parabola of this format. The axis of symmetry is taken at minus b over 2a. The roots, you can also use this one. Using the quadratic formula instead of factorization method, it's one and the same thing. You can use this to calculate the roots using the quadratic formula. So the axis of symmetry can be obtained using another way. X is equal to what? Minus b over 2a. So let's see, with this, are we going to obtain the same answer if x is equal to minus b over 2a? Remember, this is our equation. So we are having ax squared plus bx plus c. A is minus there, which is minus 1. B is 6. So meaning to say we are going to have x is equal to minus b, which is the coefficient of x, which is 6, over 2 times a, which is minus 1. This was still going to give us the same value of x, which is what? Which is 3. Or you can analyze from the roots that you are given. All right, then we are given 5.12, the y-ordinate at the turning point of the function. Remember the turning point, the y-ordinate is the value of x, is the value of y when x is 3 at the turning point, meaning to say at the axis of symmetry. The y-ordinate is from the x value, which is 3. And like I said here, this is at the turning point, which is also a solution. So if it is a root, it means y there is going to give us what? A 0. Yes, you can do the substitution, guys. It's up to you, that because you have the value of x, you can substitute. X is what? X is 3. Let's substitute and see. In place of x, y is equal to minus 3 squared plus 6 into x, which is 3, minus a 9. You're going to obtain a 0 there. All right, so that is, you can also analyze this without the understand, without like that equation. Then 5.15, you're now given to use a system of axes provided in addendum A attached to draw this graph. Indicate all intercepts with the axis and the turning point. Okay. If we are to consider shape first, we are having a negative. The coefficient of x squared is a negative. So it's going to be of this shape. Okay. So the roots and everything we are given. So this is what we are having on our graph here. So we can consider, remember the roots are at x, which is 3. So in the x-axis, this is your x-axis, where x is 3. So you're going to mark a point. Remember, we said it's a negative, so it's going to be of this nature. So this point, like I said, it's a solution. It's also a turning point. It's a solution, it's a root, it's also a turning point. So meaning to say we do not have any other solution that we are going to mark here along the x. It's at this point, because x is equal to 3 and also x is equal to 3. It's a single point that you are referring. Okay, remember the y-intercept at 0, minus 9. So you're going to have minus 9 in the y-intercept. That's another point there that you can mark, minus 9 here. These are the only points that we are having or that we are given from our graph. only points that we can use. There's anything that we can use. So with this, we're supposed to have a shape that is being drawn to have this function. So in the other case, you can also consider that 3, it's halfway. Consider also after a halfway, like at 6, what is going to happen? You can also try that to simplify on your calculator, just to check if you can have another point that you use as a reference point. All right, remember our equation? It was minus x squared. So it's minus, let's just try to substitute 6, minus 6 squared plus 6 into x, which is 6, minus 9. All right, this was going to give us a negative 9. So as we can see, if x is 6, y is negative 9, you can also use this one as a reference point, at least to draw this, because there we do not have anything. So it's actually not enough like for us to have a proper shape in this case, because we do not have points that we can use. Maybe you can just substitute 0.5 because we are given other points there. You can just do it so that at least the shape, you'll be having a proper shape to apply. So let me just consider other points here, guys, because this is not going to work the way that I want. Let's substitute when it is a 1 and see when x is 1. Since we've got points there, we can take advantage of that. When x is 1, we are going to obtain negative 4. So if x is 1, y is going to be negative 4. What about if x is 2? If x is 2, since we have a graph, we've got an advantage that we can even substitute other points there. Minus 1. So 2 versus minus 1 here. So you're going to see that 4 was going to give you minus 1. 5 was going to give you a minus 4. You're going to see that if you substitute these values, 5 like this, 5 like this, you're going to get a minus 4. And also at 4, you're going to get a negative 1 at 4. And for here, you're going to get a negative 1. So these ones like 5.5, 3.5, guys, these decimals, you can also try, but these decimals, let's just try 3.5 and see 3.5 minus 0.25, which is going to be complicated for you to mark that point because there's minus 1, minus 2. So it'll be difficult for you to mark. So these points, at least, guys, they are enough for us to have our function. At least it can give us a proper function than the one that we are given there, where we just have this, we're just having 2 points, the y-intercept and the turning point, which is the root. Only that. Guys, it was not going to give us any smooth shape there. But this one, at least you can even try to see, you can even try like to analyze like what exactly is happening, or even the shape on its own. It is going to be proper if you are having this. Since you are given points, just take advantage of those points that you are also given. So it was going to be a shape like this at the end. All right, so this was going to be our graph of y is equal to minus x squared plus 6x minus 9. So that's it. So with this, guys, we can at least have a function which is at least proper, like at least than just have 2 points. They were going to be complicated. Then on 5.2, you are given this time the function of gx, which is g. Draw this function on the same axis used in question 5.15 above on this one that we used there. Okay, let's see what we are given. That's another function to be considered, and that's a linear function. If you're to consider this, we are referring to a linear function there. We are given, it is 2x. Sorry, this is 2x over 3 plus y over 3 is equal to 1. So as you can see, the highest exponent there is 1. So that's a linear function, which we can just use the x-intercept and y-intercept. So for the x-intercept, y is equal to 0. So if y is equal to 0, what is the value of x? If y is equal to 0, we are going to have 2x over 3 is equal to 1. Cross multiply, 2x is equal to 3. Divide by 2 by 2. So x is going to be 1,5, 3 over 2. So that's our x-intercept. Remember, for a line, we just need x-intercept and the y-intercept. So the y-intercept when x is equal to a 0. When x is a 0 here, it means you are remaining with y over 3, which is equal to 1. So cross multiply, y is equal to what? To 3. So you're going to mark these points that we have the x-intercept in the x-axis. Remember, in the x-axis at 1,5. X is 1,5. So 1,5, that is here. So you mark 1,5 in the x-axis. The y-intercept, y is 3. So you're going to mark y3. And the y-axis, y is here, which is 3. So with these 2 points, they are enough. This is a straight line. 2 points are enough for us to obtain a straight line. To have a straight line, 2 points are actually enough. So you're going to join these points using your ruler. That was going to be something of this nature. All right, let me just remove this, guys, and restart it. Let me just put it aside like this so that I can draw my line. All right, so we're just going to have these points joined. These 2 points, it must pass through exactly those 2 points, exactly on those 2 points that we are given. All right, something like this. As you can see here, maybe it's because of the sheet of graph that you're given. But as you can see, that is what we are supposed to have, approximately something of this nature. So that is what you were going to obtain at the end. So we have got our g of x in this case. This was g of x. So you can write this as your g, all right? Or you can write the equation as it is, 2x over 3 plus y over 3 is equal to 1, just like that. So that was your question. And from this, you are now given to use from this 5.2 to write down from the graphs. You drew from that part, okay? On the answer sheet for the above questions, the coordinates of the points of intersection of the graphs, f of x and gx. Our f of x and gx, they intersect. Where they intersect, what are the values of x? So here it's not going to be that clear, guys, but this is what you're going to do. You are going to take from the point of intersection straight to the x-axis. The corresponding value was going to be your answer there. It was going to be at 2 or maybe 2,1 somewhere there. And this one, they also intersect here straight to the x-axis with your ruler. So it was going to correspond there at a certain value. I don't know, guys, it was going to be 5,6 or 5,7 somewhere there. So you have to consider exactly from your graph. That is how you're going to take these x values. All right. Then let us consider 5.3. On 5.3, we are given the functions of s, which is y is equal to 1 plus cos of x, and that of t, which is 1 minus cos of x from 0 to 180. Copy and complete the table. So it was just a matter of copying and completing this table. So in this case, I'm just going to substitute straight. Sx, which is this one, is the one for y is equal to 1 plus cos x. So you substitute these values that we are given in place of x. So that was your question in that case, all right? So also your answers there, as you can see, they are to 3 decimal places. You can also fix your calculator to 3 decimal places in case that they are decimals on your simplification. All right, so let's start with this one. It was 1 plus cos x. 1 plus cos. Make sure that your calculator is in degrees. There is a D here on your calculator. So the first one, that's a 0 there. You are going to obtain a 2. All right, we move on to 60 degrees. Going to substitute 60 degrees. That was going to give us 3 over 2, which is 1,5. So that's 1,5. We move on to 90 degrees. All right, 90 degrees was going to give us a 1. So this was going to give us a 1. We move on to 120. 120 degrees. So we're just going to substitute here 120 degrees. Let's see, that was going to be what? 1 over 2, which is 0.5. We move on to 180 degrees. That's 180 degrees. All right, I was just supposed to leave it like that. That's a 0 there. All right, you do the same thing on tx, but tx is this one, which is 1 minus cos x. So this time we must have a negative here. So we are going to have a minus. All right, so let's start with a 0. The first angle that we are given, that's 0 degrees. So that's 1 minus cos 0, which is going to give us what? A 0 there. So the first one was going to give us a 0. We move on to 60 degrees. That will be 60 degrees, which was going to be 1 over 2, which is 0.5. 90 degrees, like that. 90 degrees was going to give us a 1. 90 degrees is giving us a 1. Okay, that's the point of intersection. This one you can see when it is like that. All right, 120. You do the same thing. That's 3 over 2, which is 1.5. At 180 degrees, you're going to do the same thing. That was going to be a 2. So with this information, with this table that we have just completed, now we are asked to use the system of axes provided in addendum B to draw these two graphs from this information that we are having. All right, so let me just remove this one, guys, and work with the one that we need there. So with this information, let's try and mark out our points. So you need to indicate the points that you are given. So we are going to start with the one for SX. That is the first one that we are given. We are considering this one, SX, this one. So we are going along these values. Along these values, all right? These are the values that we are going to mark corresponding to the angles. So that's 0 versus 2. 0 versus 2. All right, gonna mark 0 versus 2. When x is 0, y is gonna be 2 here. That's 0 versus 2. The other one, it's 30, but look at that decimal, it's gonna be complicated, 1,866 like that. So just mark it 31,8 according to our scale. 1,86 can be maybe somewhere in between there, because here, according to the scale, this is 0,1, 0,2, 0,3, 0,4, 0,5. Okay, so each box is 0,1. So that will be here, it's going to be 1,9, 1,8. So 1,86, it's in between. You cannot mark that point exactly to say it's here. So just mark like just approximately there. Then 30. The other point, 60, it was versus, we're just going to take these ones, 1,5, 90 versus 1, and so forth. So it is 60 versus 1,5. 1,5, we can see it here. This is 1,5. Remember, 90 was versus 1. We can see it, the 90. We move on. All those points, 120 was versus 0,5. 150 was versus 0,134 and so on. So this is 1, 2. So 1,34 is just going to be complicated somewhere around there. 180 was at 0 there. So this is what you're going to have for your SX, which means you were going to join the points to have your function. All right, just something approximately like this. This is what you're going to have. So that is the function of SX, which is the one of 1 plus cos x, which is the one of 1 plus cos x. We move on to the other one, doing the same thing, marking these points corresponding to the angles, like what we had is going to be 0 versus 0, 0, 30 versus this, and so on and so on, up to the last one. All right, so we have got the first one, 0 versus a 0. That's a 0 and a 0 here. 30 was versus 1,3, somewhere like that point that we had, guys, before. It's just going to be approximate there. 60 was versus 0,5. 90 was versus 1. 120 was versus 1,5. 150 was versus 1,866, which is that value that we had before, guys, somewhere there. 180 was versus a 2. So as we can see, we are going to have a function drawn passing through these points. All right, so just going to be roughly something of this nature. We're going to have roughly something like this. So this was the function of tx. Remember our tx, which was 1 minus the cos of x, just like that. So it was just a matter of marking the points, joining the points. 5.33, write down from these graphs you drew on this answer sheet, okay? The coordinates of the points of intersection of the graphs SX and TX. As we can see, SX and TX, they do intersect. You can even see it from the table. You can take it from the table, or you can even see it from the graph here. They intersect here. What are the coordinates? Remember the coordinates always, whenever we are referring the coordinates, we talk of the X versus Y. So they meet here, but what is the X value? 90 degrees. These are angles in degrees. So it is going to be 90 degrees versus Y there. Y is what? What is the value of Y at the point of intersection? Y is 1. Y is not in degrees. It is X, which is in degrees, not Y. All right, so that is what you're supposed to have, and you're supposed to be very, very careful with your simplifications. In whatever simplification that you are going to have, you must be very, very careful. All right, let's consider another part where we are given. All right, let's see what we are having on the other hand. So on the other hand, we are given question 6, which is convert 47 degrees, 24 minutes to decimal degrees. They just want the answer in decimal degrees. That is degrees only. We are supposed to see degrees only. So it was a nice question. This one, it was just to convert the 24 minutes to degrees. Remember, 1 degree is equal to 60 minutes. So what about 24 minutes? How many degrees do we have? So simply going to divide by what? By 60. So that's 24 divided by 60. Whatever that you are going to obtain there is going to be what? In degrees. So that was going to be 0,4 in degrees. So meaning to say we have got 47 degrees plus 0,4 degrees, which is going to be 47,4 degrees as a decimal, only in degrees. So that is what you're going to have in this case. 6.2, we are given a circular pieces, that is a circular pieces of cheese with radius 4 centimeters is divided into 6 equal pieces. So we are given a circular cheese like this. It's in a form of a circle. It has a radius of 4 centimeters, but it is divided into 6 equal pieces. These are sectors. There's a sector here, a sector here, a sector here, a sector, 6 of them. 1, 2, 3, 4, 5, 6, like that. There are 6. So the question was 6.21. Calculate the following: the angle in radians subtended by each piece at the center, by each piece. Out of these 6 pieces, we are going to have each represented like this as a sector. We are going to have something like this as a sector 1 of each. What will be the angle there? So remember, they are divided into 6 equal parts. So it is going to be 360 degrees divided by 6 if you want to write in degrees. But remember, this is what in radians. 360 degrees, we know this in radians is 2 pi. Since they want the answer in radians, 360 degrees, a complete revolution is 2 pi. So it's simply 2 pi over what? Over 6 pieces. Just like that. So you're going to divide this, which was going to be pi over 3. So the angle there that they wanted was going to be pi over 3. That is the angle of each sector in radians. Since we are given this is supposed to be in radians. 6.22, the arc length. There we need the arc length. The arc length of each piece of each, not like for every, that just each, like if you consider each piece. Remember the angle we have pi over 3. The radius we have, it's 4 centimeters. And from our formula sheet, the arc length L is given as r theta. That is radius times theta in radians. Radius is 4. We have got our radius, which is 4, and our theta, which is pi over 3. So that was going to give us, which is 4 pi over 3. You can just write as 4 pi over 3, or as a decimal, we can have this as, let us just try to convert here. 4 times pi over 3. That will be 4,8 and so forth. You can even fix this to 3 decimal places. That's 4,189. That's 4,189 in centimeters. Arc length is measured in centimeters. So that is what you are given. All right, that's 6.22. 6.23, the area. So remember the area of the sector is of each, meaning to say to consider of a sector. So this is given as half r squared theta, like that. We can consider half r squared theta. Also, these formulas, like I said, you are given these formulas, so you need to understand your formulas. So we can use this formula direct, that is to obtain what? Our area. So area is going to be half times the radius squared. Radius, remember, it's 4, so it's 4 squared times theta in radians. Remember our theta in radians is it's pi over 3. So that's it. Let us just simplify this direct on our calculator. What are we going to have at the end? So that is 1 over 2 times 4 squared times pi over 3, okay, times pi over 3. All right, so that was going to give us 8 over 3 pi, or 8,378, 8,378 square centimeters. So then we are referring to the area. We are referring to the area of each piece, not like the whole cheese, but the each on its own. All right, 6.3. So these were our questions direct like that. 6.3, we are given, in this case, a wheel completes 2,460 revolutions per minute. So we've got the speed in revolutions per minute. That is 2,460 revs per minute. Calculate the following. 6.31, the number of revolutions completed per second. Guys, from per minute to per second, we are simply dividing by what? By 60. So this is simply dividing by 60 in that case. So that was going to give us 41 revs per second. Then 6.32, the angular velocity of the wheel. So remember, the angular velocity is measured in rad per second. There we are calculating omega in rad per second. So omega is given as 2 pi n, which is 2 pi times n. We already have our n in revs per second. So that was going to give us 81 pi rad per second, or as a decimal, 257,61, something like that, rad per second. So that's it. You have got the angular velocity there. 6.4, you were given that the height of a segment is, and also the length. So this one, you just need your formula. So remember, we are also given this from our formula sheet. Let me just show you guys on your segments of circles. So from the segments of circles here, the chord length, everything. Then we've got our formula here. So this is what you're supposed to use to find whatever that you are given there. So we are given that the height is 14. This is the height. The length of the chord is 3,5. So remember, the chord length is x. So we've got x there. You're asked to calculate the radius, and we do understand that radius is diameter over 2. The formula is not given in terms of radius, it's given in terms of the diameter. That the diameter is given as h plus x squared over 4h. This is our formula from the formula sheet, where d is the diameter. So you're going to substitute your height, which is 14, plus x squared, our x, which is the chord there, 3,5 squared over 4 times h, which is 14. You are obtaining the diameter in this case. All right, so this is what you're going to have, 14 plus, let's have a fraction here, 3,5 squared. All right, this is 3,5 squared, everything over 4 times 14. That was going to give us 49, this, whatever that you're having there, divided by 2. That was 7 point. All right, let's before that, let me have it as it was before. It was 14.219, okay? 14.219 centimeters. This one is your diameter. We can obtain the radius from there. So the radius is this answer divided by 2. So that's 14.219, then divide by 2. You are going to obtain 7,110 like that. So that was our radius. Remember, the radius, it's half of the diameter. The formula is for the diameter. Calculate the diameter, then find the radius from there. 6.5 we are now given. In triangle ABC, okay, there's a 90 degrees there. We are given BC and angle of so it's a right angle triangle since there's a 90 degrees there. So it means this triangle is a right angle triangle. So you can just have a sketch. And the right angle is at what? At angle B. So this will be our B. So you're going to call it ABC or ABC, the way that you want, ABC. So B is the one that is at 90 degrees. It must have a right angle like that. BC, 27 centimeters. So this is 27 centimeters. Angle A is 36 degrees. This is 36 degrees like this. So you just needed a sketch. So 6.51, it was to calculate the value of AC. That is the length of AC. This one, AC. We can use our trigonometrical ratios, guys. As you can see, we have got an angle here. According to this angle, AC, this BC that we are given is the opposite. AC does not change. This is the hypotenuse, the one that faces the 90 degrees. Which ratio from our SOHCAHTOA concept, which uses the opposite and hypotenuse at the same time? That's the ratio of a sine. Okay, so that means you are going to use the sine. The sine of theta, 36 degrees, is equal to the opposite over hypotenuse, opposite, which is 27, over the hypotenuse, which is AC that you need to calculate. You can calculate AC from there. Just cross multiply, then divide. So it's AC times sine 36, which is equal to 1 times 27, which is 27. So you can simply divide by the sine of 36 both sides, the sine of 36 both sides here. This was going to give us AC. So 27 divided by sine 36. Let's see, what are we going to have on our calculator here? 27 divided by sine 36. This was going to give us 45,935. So that's 45,935 centimeters. All right, let's check the units. These are centimeters, so our answer is going to be in centimeters also. That is, we can use those the part of our ratios to answer this part. that is in your hands, guys. The same thing even with this part here, 6.52. To calculate the length of AB, since you have AC, you can substitute AC, use Pythagoras theorem to calculate AB, or you can even use the trigonometrical ratios again, because this time we need this AB, sorry, we need this part of AB. And according to the angle that we are given, this part of AB is the adjacent. So where do we have adjacent and opposite at the same time? Tan. So thus we can calculate AB from there. Since the tan of theta, the tan of the angle, is equal to the opposite over adjacent. Opposite, which is 27, over the adjacent, which is the AB that we are supposed to calculate. We can also calculate this, cross multiply this and that. So AB was going to end up as 27 over tan 36 degrees. So there we were going to calculate our AB just like the previous case. We can use our calculator again, 27 over sine over tan. This time it's tan 36. So that's 37,612 to 3 decimal places, 37,162, sorry, in centimeters. That's 162. So we have got our AB there. Then another question, it was to calculate the value of 1 minus cos 2c. 1 minus cos 2c. Okay. What is representing angle C? That is the question. Then we just need to ask this because we can use our calculators. We can use our calculators, guys. What is the value there? All right, 6.53. From these angles, angle C can be calculated. Remember, angles in a triangle, they add up to 180 degrees. So you can subtract the 36 degrees and the 90 degrees from 108 to obtain angle C, which is simply 54 degrees. So this is our angle C, 54 degrees. So the question is simplify 1 minus, that is our question here, 1 minus cos 2c. So this is going to be what? This is going to give us 1 minus cos 2 times c, angle C, angle C. What is angle C? Angle C is 54 degrees. So there we can just use our calculators straightforward. 1 minus cos 2 times 54, that is 108 degrees. So we can use our calculators again. So that is 1 minus cos 108. 1 minus cos 108. All right, so that was going to be 1,309. Okay, 1,309, just like that. Okay, so there, it was just a matter of simplification, guys, nothing much. It was just to find your angle, then you simplify. So you've got 6.53 there, which is 3 marks each question there, okay? It was 2 marks each question out of the 3 questions, 2, 2, 2, like that, all right? 6.6 we are given. The tan of theta is minus the square root of 11 over 14 from 270 to 360. Which quadrant is this? From our quadrant, this is 090, 180, 270 to 360. We are talking about the last quadrant, the 4th quadrant, okay, which is fine. We are given a ratio of a tan under a single square root. Guys, remember that the square root of A over B can also be written as the square root of A over the square root of B. So whatever that we are seeing here under the square root is not supposed to scare us. It is just the same thing in this case here as, okay, this is our theta. It is just the same thing here as we have got minus the square root of 11 over the square root of, this is what it means. So remember the tan of theta from that SOHCAHTOA concept, tan opposite over adjacent. So it means we've got the opposite there, the adjacent. So the opposite minus square root of 11, adjacent square root of 14. So the question was, with this information, find the value of sine theta or calculate the value of this without a calculator. So to obtain this sine of theta from our SOHCAHTOA, we saw that the sine of theta is going to be opposite over the hypotenuse. So definitely we'll need opposite and also the hypotenuse, which we do not have the hypotenuse. So we can calculate first the hypotenuse. From where? Pythagoras theorem. From our Pythagoras theorem, remember hypotenuse squared is equal to side squared, side squared. So that will be the square root of 14 squared plus minus square root of 11 squared. So this was going to give us 14 plus 11, and that was going to give us 25 at the end. So finding h squared, finding h, introduce the square root. So h is the square root of 25, which is 5. So meaning to say our h there is 5. So having h, we can calculate now the ratio of the sine of theta, because the sine of theta is the opposite. And the opposite is what? Minus square root of 11 over the hypotenuse, which we calculated, and that gave us what? A 5. So with this information, you were going to obtain actually full marks for that. And that is our question paper, guys. This is how you're supposed to attempt these typical questions. I do not know if there is any other way or any other method that you can consider in your simplification. Let me know so that we can work on that in other revisions, and also make sure that you join the membership so that we are going to have our revisions in this preparing for our N3 so that you can start working with your N3 now as we are revising towards the exams which are ahead of time. So this is what you had, guys, from Maths on African Motives. Till we meet again.